Alright, so let's continue with enabling learning objective B and C. Uh, B is identifying the 5 rules of direction, so how do you find your direction to target? And objective C is putting together a polar call for fire that depends on your, again, your direction to the target. The 5 rules of direction can be described by the acronym OMG 10-4. But I don't know if you have to have that memorized in great detail, but the first part is the direction is the observer to the target. Sometimes there's some confusion that thinks it's the direction from the firing system to the target. That's called the gun target line. That's not your problem. All you are worried about is the direction from you, the observer, as represented by the red triangle, to the target, that silhouette in the top right that looks kind of like an Abrams, so maybe not the best target silhouette. Anyway, when you communicate that direction, you're going to use mils. You're not going to use degrees like you normally do with a compass when you're doing land navigation. There are 6,400 mils in a circle. If you look at your compass, there are 2 rings. There's the degree ring that you most often use when you're doing land navigation, and then there's the mil ring that has or corresponds to the numbers you see on the screen right now. So 0000 is due north, 1600 or 1600, excuse me, is east, 3200 is south, and 4800 is west. It's a little more precise than degrees because it divides the circle up into more smaller pieces of the pie, and we'll talk about how that works in a minute. You can also use a grid to find directions. So we've got our OP down there in the bottom left again, and you are trying to plot a line from your observation post to the target. Now let's say you've got a map, and thanks to terrain association, maybe some road placement, you're able to figure out where that target is. You also know where you're at, so you have 2 dots on your map. A dot here at the OP and a dot over here where the target is. You can draw a line between the OP and the target, and then use your protractor, as represented by this 90-degree intersection here, to calculate the angle the same way. Excuse me, to calculate the direction the same way you would if you were finding the direction on a map for a plot or point you wanted to travel to in land navigation. This could be really helpful if you were on a building or near some kind of physical feature that gave off a lot of electromagnetic interference. If your compass isn't working, how can you find a good direction to your target? Well, you can find a good direction to your target by using terrain association, your map, and your protractor, and then plotting that direction. We communicate direction down to the nearest 10 mils. So you won't give a direction smaller than 10. In this example, we round 12 to 10. We round 17 to 20. We round 825 to 820. And then 1631 to 1630. We'll always communicate those in 4-digit terms. That way, when someone's listening on the radio, they don't get it confused with degrees. For example, if I was just to say direction 70, a untrained soldier who doesn't know the difference between mils or degrees for fire support may think that we're talking about 70 degrees. So it's especially important when you're operating or when you're describing mils that are below 360, you have that 4-digit format. So 0100, 0010, 0070, and so on. Always give 4 digits with your direction. Alright, now let's put this into practice with a polar call for fire. I recommend using the polar. I think it's the easiest for you as an observer or a non-MOS qualified forward observer. But we'll talk about grid in another video. But for right now, let's just focus on polar. Now for a polar call for fire to work, the fire direction center or the fire cell at the squadron TOC needs to know your location. If they don't have your location, they cannot facilitate the polar plot to identify the target location. So when you check in as an observer the first time, you need to report your observer location. Then once you've reported your observer location, you can call for fire. To do that, you need direction and distance. Those are mandatory every time. If you have a change in elevation of greater or than 35 meters, either up or down, you need to send that change in elevation. But direction and distance are mandatory. As I mentioned in the first video, a Scatatuck is kind of flat. You may find that you're not going to see a 35 meter elevation change. Now let's look at the example here. So we have a target and we have an observer. The OP is represented by the green triangle with the black interior. We see our altitude. It's masked by the control screen there, but our altitude is 155 meters. We see the target altitude is 200 meters. So take 200, subtract from 155, and decide if you need to make an up-down correction. Take a moment right now and try to fill in the blanks for this polar target. So your first transmission that includes the first two elements of the call for fire. Ghost 84, this is Shavetail 01, adjust fire polar over. You included the station identification, that's Ghost 84, this is Shavetail 01. And adjust fire polar lets the fire cell know what type of mission it's going to be. Now in our second transmission, we send the target location. Direction 1600, distance 2200, up 45, over. Now we begin our third transmission. One tank stationary in the open, over. And that completes the polar call for fire. Let's try another one. Go ahead and pause the video for a moment and determine your call for fire. The correct polar call for fire should be Ghost 84. This is Shavetail 01. Adjust fire polar over. Direction 2100. Distance 1500 over. One tank stationary in the open, over. Now notice there was not an up-down correction. If we compare the altitude of the OP, 155 meters, to the altitude of the target, 145 meters. We subtract those two, there's a 10 meter change. That 10 meter change is less than the 35 meters required to make an up-down adjustment, and we just leave that part out. It's not required. Now as you conduct the call for fire, each transmission you send will be read back by the Fire Direction Center. There's no Roger or good copy. We are reading back every transmission to make sure that we are completely synchronized and in agreement about what's going to happen. A couple sloppy numbers misread or miscopied can lead to a friendly fire incident, and you want to avoid that, obviously. All right, go ahead and pause the video again and try to complete this call for fire. Alright, the correct answer is Ghost 84. This is Shavetail 01. Adjust fire polar over. Direction 2510. Distance 2500. Down 80 over. One tank stationary in the open, over. Now, the OP altitude 300 meters. Target altitude 220. 300 minus 220 is 80. That gives us our down 80. And then the distance and direction are both provided. So what does the Fire Direction Center need to know prior to a polar mission call for fire? Your location. You have to send your location if you are going to do a polar call for fire. If you do not send that, they will call and ask you for it. You will get dinged for it. So report your location. What increments do you send direction? Increments of 10, when sending distance, you send it to the nearest what? 100 meters, and I don't think there was a slide for that. So anytime you're sending distance, round to the nearest 100. The only time you can make an adjustment of 50 meters is when your next transmission is going to be a call for fire. So you might send an initial distance of 800 meters or 2,000 meters. When you get to that final correction, if you just want to move it a little bit, you can give drop 50 fire for effect or add 50 fire for effect if you want it to move a little further or a little closer to you or a little further away, respectively. Alright, that's the end of the polar call for fire. We'll pause here and then I'll provide you with a grid call for fire next. It's good timing.